Okay, this is our lesson on the loudspeaker. What we're trying to explain is how a loudspeaker works, and in the lab you might have built a loudspeaker, which obviously we won't do on this, but you can see loads of videos on YouTube about building loudspeakers. Okay, so what's inside a loudspeaker? Possibly that your teacher may have got one of these out and showed you a cutaway, but you can see there's a paper cone suspended by this sort of rubber around the edge called the outer suspension, and this cone is attached to a coil. And this coil of wire is embedded within a magnet, and the magnet here on this diagram is yellow. Okay, so we've got this coil can move, so it's a moving coil inside a magnet that's fixed, a permanent magnet, and the coil is attached to a paper cone. So if the coil is forced to move, it moves the paper cone, and if the paper cone is forced to move, that moves air, because this has got quite a large surface area, so it's very good at moving air and forcing air to vibrate. And you know from the study of sound that you've done so far in school that when you move air and vibrate air, well, that's exactly what sound is. Sound is the vibrations of air being transferred through the air and ending up on your eardrum possibly. Okay, so more of a physics diagram here, so you can see I've tried to show the magnet, so this would be our North Pole at the top, and I've showed a coil of wire going round the magnet, so you've got to imagine that there's a coil of wire. I'm just showing you a cross section through it. These crosses means this is a wire with electric current in it going away from you, and these points means that this is the cross section of a wire with electric current coming towards you. Now what you can do by using the left hand rule, we can show that the force on the right hand side of the coil, so this side of the coil with the current coming towards you, is in a particular direction, and the force on the left hand side of the coil, these crosses where it's going away from you, is in the opposite direction, and this makes the cone move. So this is what's happening. Okay, that cone sort of moves upwards, and this is because there is a force on that wire. And if you do the left hand rule, obviously you'd have to your magnetic field finger points out of the screen. Okay, sorry, it points into the screen, and I'll start again. The current finger, so the finger which is the direction of the current, points into the screen on this side. The magnetic field finger sort of points across the screen from right to left, and you should have the force being up. And on this side, because the field is in the opposite direction and the current is in the opposite direction, then the force is in the same. Okay, so here we'd have the force on the right side of the coil is up, on the left on the side of the coil it is up. So this makes the cone move up. Now, when you reverse the currents, if I just go back a few steps, okay, that's moved the cone up. If we reverse the current, so on this side of the coil, if we make it a dot, which means coming towards us, and this side of the coil we make a cross, which means going away from us, then everything will reverse and the cone will be forced downwards. Okay, so all of this up forces the cone upwards, and then if you reverse the direction of the current, then that forces the cone downwards. Now, when you use alternating current, this happens all the time, so the direction of the movement of the speaker cone matches what the alternating current is doing, and we would say the frequency of the alternating current matches the frequency of the loudspeaker's movement. And remember, the reason it moves is because there's the coil in a magnetic field, and when electric current flows through that coil in a magnetic field, there is a force on it, just like you've looked at in the magnetism topic. Okay, so with alternating current, this happens over and over again, making the coil vibrate. And as we've said before, the surface areas of the cone causes a lot of air to vibrate, and we hear that as sound. Okay, so if you might have labelled the diagram, so the magnet would be the grey area, the cone is this blue surround, the coil is red, and the electrical connection will be these two red connectors here. And you could write a sentence to explain how it works, which we'll come to in a second. Just before that, there is a website here listed at the bottom, which has got this really lovely animation. It's animagraphs.com loudspeaker. This is way too complicated than what you need to know for GCSE, but if you spend some time looking at that, you can see the coil of wire, and you can see the magnet that it's surrounded by, and as the direction of the current changes in the coil, you can see that the force on the wire, the force on the coil, as the direction of the electricity in the coil of wire changes, the force on the wire changes, which forces the coil in and out. And there's quite a few, and there's quite a lot of animation. If you go down the page, it tells you all about the cone and how sound waves are made. So really nice website. If you can get onto that, it's animagraphs.com. Okay, so if we come back to here, just a bit of a summary then. So overall, how does a loudspeaker work? A loudspeaker consists of a coil of wire wrapped around a permanent magnet. When an electric current flows in the coil, it becomes an electromagnet. Alternating current is used, so the magnetic field is changing. The coil is first pushed up and then down by the fixed magnet. This makes the coil vibrate, and so the cone produces a sound with the same frequency as the alternating current input. Okay, so lots to think about in the loudspeaker, but fundamentally it is all to do with what's known as the motor rule or the left-hand rule, and this is a force on a current carrying conductor in a magnetic field.